Hi everyone, and welcome to my online course for research methods in psychology. My name is Frank Losciavo, and I am your instructor. I have a few interesting things to show you, so sit back, relax, and enjoy the show. As you know, our second research project involves conducting an experimental study testing if visualization instructions help relieve student anxiety and stress. Our ultimate goal is to communicate our findings by writing an APA-style research report, but first, we need to use Jamovi to analyze the data we've collected. And that, my friends, is what this video is all about. If you haven't already, download and install Jamovi. It's free and it's awesome. I strongly recommend using a Mac or a Windows-based PC because the installation process is more complicated when using other devices such as a Chromebook, and you can download the most recent solid version right here. All right, let's take a look at our instructions. We've talked about Jamovi, so that puts us right about here. From our course website, what we need to do now is download the Excel file that contains our research data. It's entitled Psych2120 Project 2 Data.xlsx. And you're going to save that file to your hard drive because in the next step, we'll import that data into Jamovi. As you can see, I have that file right here in my Downloads folder. Now that we've saved that Excel file to our hard drives, we want to open it within Jamovi. Once you've opened Jamovi, click on the hamburger menu and then click on Open. Now we need to find the Excel file that we just saved to our hard drives. So I'm going to click on Browse. It's loaded in my Downloads folder. I'm going to click on that Excel file and then open it within Jamovi. And just like that, our Excel data file is imported inside of Jamovi. Let's go ahead and save this Jamovi data file. Go ahead and go to your hamburger menu and click on Save. Now we need to find a safe place to store the file. So I'm going to browse. I'm going to put it in my Downloads folder. And I'm going to call this file Psych2120 Project 2 Analyses.omv. All Jamovi data files end in a .omv extension. The nice thing about a Jamovi data file is that it saves all the data and all the analyses all within that one file. Now that the Jamovi data file is saved, let's format each variable with the appropriate attributes. But first, let me refresh your memory about the questions we asked in this research study. The specific questions asked in your research project might be different, so just follow your printed instructions. In this particular example, these first 5 questions served as our main dependent variables. And you can see they're all formatted similarly. They all use the same 5-point response scale. So within Jamovi, we'll set up each question in the same basic way. To set up our data file, click on the Data tab and then Setup. This first variable contains the response ID number that Qualtrics assigned to each one of our participants. We don't use this variable in our analyses, so there's nothing we really need to do to set it up. However, if you'd like, you can change the measurement type from nominal to ID. Let's go ahead and set up that next variable. First, let's enter a brief description. This question asked about anxiety and stress when thinking about remaining assignments and activities that a student must complete for their classes this semester. So I'm just going to enter anxiety and stress thinking about assignments. Using the response scale that we provided, students were able to select from no stress, mild stress, moderate stress, severe stress, or extreme stress. So the measurement type used an ordinal scale. As you can see by looking in the spreadsheet, the data are all entered as integers, so data type is fine. But let's take a minute to enter variable labels for each of those 5 levels. 1 represented no stress or anxiety. I'm then just going to hit my tab key to move to the next level. 2 represented mild stress and anxiety, so I'll just type in mild. And then again, I'm going to tab to get to the next level. 3 represented moderate stress or anxiety. 4 represented severe stress or anxiety. And 5 represented extreme stress or anxiety. You can hit tab so that's entered in, and then also click right here on Retain Unused Levels in Analyses. Then we can just use this arrow to move to the next variable, and then go ahead and set that up. I've shown you how to set up these variables already, so go ahead and pause the video and then take some time to set up the remaining variables. Thanks to the power of video editing, my jamovi data file is now all set up. So at this point, I'm going to close the setup window. All right, now we're ready to run some basic analyses. That brings us to about right here in the instructions. So next, we're going to visit the Analyses tab and then click on T-Tests. And then we'll select Independent Samples T-Test, because what we want to do is run an Independent Samples T-Test on each of those main dependent variable questions. Of course, our grouping variable is going to be condition, because we want to compare the 2 groups, the 2 conditions that we ran. We had a control condition and an experimental condition. So long story short, we'll be running 5 separate t-tests, 1 for each dependent variable. Let's click on the Analyses tab and then select t-tests. And then from there, let's select the Independent Samples t-test option. For this example, we want to compute independent samples t-tests for question 2A, 3A, 7A, 9A, and 10A. So we need to move each of those variables into the dependent variables window. We can do that one at a time, or by holding in my control key, I can select multiple variables at once and then move them over. As I mentioned previously, the grouping variable will be condition, because this will allow us to compare participants in the control group against participants in the experimental group. So go ahead and click on condition and then move that over as the grouping variable. If you look over in the results window, you can see that jamovi is already computing these analyses. However, we want to still add a few different options. By default, jamovi will run a student's t-test, which is the same type of t-test that you learned in your statistics class. Also by default, jamovi will run a two-tailed or non-directional t-test. Theoretically, we could find statistically significant results in either direction, so that's the option that we want. Go ahead and click on Mean Difference. Jamovi is now going to add to the table the difference between the 2 group means, and it'll also compute the standard error of that difference. Go ahead and click on Confidence Interval as well. You might recall from your statistics class that a 95% confidence interval is equivalent to doing a t-test with an alpha of 0.05, which is the alpha level we typically use for psychological research. So be sure to set that confidence interval to 95%. It's nice to have an effect size estimate as well, so go ahead and click on Effect Size. As you can see on the right side of that output table, jamovi included a column for Cohen's d, which is a standardized measure of effect size. Of course, we're running these t-tests so that we can compare the control group with the experimental group. So it makes sense that we'd want basic descriptive statistics like means and standard deviations and sample sizes for each group. So go ahead and click on Descriptives. That's all we're going to need for our t-tests. That brings us to about right here in our instructions. We don't want to forget about the other variables that still remain on our list, So, for example, we had age, gender, school status, and condition. Of those variables, only age is quantitative. So for that variable, we're going to want a mean and a standard deviation. The other variables are categorical, so we'll compute frequency distributions for each. To add those analyses, we still want to be in the Analyses tab, but now we're going to click on Exploration, and then on Descriptives. Now let's select each of those variables that we just discussed and move those over to the Variables window. And just like that, Jamovi gets started working on some basic descriptive statistics. Go ahead and click on Frequency Tables so that Jamovi will create frequency distribution tables for each of the categorical variables. To make that first table a little bit easier to read, let's change this from variables across columns to variables across rows. Let's check out the statistics options. One thing we're going to want to add is the mode. And you'll see that Jamovi adds a column for mode in that first descriptives table. The good news is that for now, those are all the statistics that we need. If you'd like, you can click on Edit and then add labels to the various output tables. Now that our output tables look pretty, we can export our results so that we can more easily view them outside of Jamovi. To do that, within the results window, right-click, and then select All, and then select Export. You'll want to find a safe place to store that PDF file, so browse your computer. I'm going to store my PDF file in my Downloads folder, and I'm going to call the file Psych2120 Project2 Analyses.pdf. I'm going to click to save that. I already have that file, and I'm going to say I want to replace it. Let's go ahead and open up that results file and take a look at what we see. Here's that PDF file right here. Let's open it up. Let's take a look at the first row of this table. This is the t-test for question 2A. Just to get a basic sense of what's going on, let's take a look at some of those statistics. First, we can see that we have 50 people in the control group and 50 people in the experimental group. Now keep in mind, this is just some sample data for demonstration purposes only. This won't coincide with the actual data that you collected from your experiment. The next thing I want to look at are the group means, and I want to see if they're in the right direction, to see if they're in the predicted direction. Remember, the people who were randomly assigned to be in the experimental group, they received some additional visualization instructions. So I'm hoping that they will have less stress, less anxiety. In other words, I'm hoping that their group mean is lower than the group mean for the control group. And in this case, it is. So let's focus our attention above now on that independent samples t-test. For that particular difference that I was just looking at, for question 2A, I can see a t-statistic of 3.14, and that's a relatively large t-statistic. I can see that I have 98 degrees of freedom, and you might recall the way we compute degrees of freedom is the total number of subjects, which in this example is 100, minus 2. 100 minus 2 is 98 degrees of freedom. And then this next column is very important. That shows us the exact p-value. And we want to compare that p-value, that probability value, with our alpha level. And you might recall that in psychological research, the alpha level that we typically use is 0.05 or 5%. So any p-value that we see that is less than 5% would be a difference that is statistically significant. So when I look at that value, I see 0.002. That's essentially 0% plus a little more. That's clearly less than 5%. So this particular independent samples t-test, that's looking for differences between the control and the experimental condition, it is statistically significant. What that p-value is telling us is that the probability of finding those group differences just due to sampling error is very, very small. So we have effectively ruled out sampling error or chance variation as a viable explanation for the differences that we see. In other words, the differences that we see are due to our manipulation. So in this case, the students that received visualization instructions do indeed report less anxiety and stress. This column right here shows the difference between those two means. This shows the standard error of that difference, and here's a 95% confidence interval. That's a 95% confidence interval around that mean difference, and you can see that that interval does not include 0. We have effectively eliminated 0 as a viable value for the difference between the two groups. In other words, there is a difference between the two groups. The difference between the two groups is not 0. And finally, this last set of columns is for Cohen's d. Cohen's d measures effect size in terms of standard deviation units. So when we ask ourselves, how big is the difference between those two groups, the difference is about 0.6 of a standard deviation. So the students who received visualization instructions, they reported less stress and less anxiety. How much less stress? How much less anxiety? About 0.6 of one standard deviation. In psychological research, that's a relatively large effect size. So to summarize, for this first test, for question 2A, we found statistically significant results, and those results are different in the right direction. The students who received visualization instructions reported statistically significantly less anxiety and stress. And this is how we would summarize that test if we reported it in a research report or a journal article. As you can see, we conducted a t-test with 98 degrees of freedom, and the value for that t-test was 3.14. The probability of finding that data just by chance, just due to sampling error, is 0.002. That's a very small value, and it's smaller than our alpha level of 0.05, so it's statistically significant. That's based on a two-tailed test with a Cohen's d equal to 0.63. Let's take a quick look at the next t-test, the one for question 3A. Let's first just scroll down a little bit and look at those group means. Again, those group means are in the right direction, the predicted direction. The students in the experimental group, the students who received visualization instructions, they reported less anxiety and stress than students in the control group. So that's good news that we have a difference in the right direction. But now the question is that difference statistically significant? So let's go back up and look at that t-test. Here are the results for question 3A. Here's our student's t-test. We can see that that t-value is 1.21 approximately. That's not a very large t-value. Again, that particular test is based on 98 degrees of freedom. However, in this case, we can see the p-value equals 0.23. That's like about 23%. And 0.23 is clearly not less than 0.05, which is 5%. So in this particular case, we do not have statistically significant results. In other words, the differences that we found are the differences that we would expect to find just due to sampling error, just due to chance variation. Just like before, we can see the mean difference. That's literally the difference between the two means. We can see that the difference between these two means is less than the difference between the two means in the example that we looked at previously. This is the standard error of that difference, and this is a 95% confidence interval around that difference. And you can see that within that range, within that interval of values, is the value 0. So we have not effectively ruled out the value 0 as the difference between those two groups. In other words, it's still reasonably likely that there is no difference between those two groups. So long story short, even though those group means were in the predicted direction, the difference between them is not statistically significant. So we don't want to make a big deal about those differences. This is how this particular t-test would be summarized in a research report or a journal article. We conducted a t-test with 98 degrees of freedom, and the value that we computed was 1.21. The probability of finding those results just due to sampling error, just due to chance variation, was equal to 0.23. That was based on a two-tailed test, and the effect size, Cohen's d, equals 0.24. That particular test is not statistically significant. Let's just go over one more example for question 7a. Let's scroll down and take a look at those group means. You can see in this case, the group means are not in the predicted direction. In this particular case, the students assigned to the control condition actually reported less anxiety and stress. So as far as our predictions go, that's not a good thing. But remember, we're doing two-tailed tests, so we might find statistically significant results in the opposite direction. Now, that would be somewhat strange, but of course it could happen. So let's go ahead and take a look at our t-test. Here we can see that the t-value is negative. And this is because when jamovi computes the t-test, it takes the value from group 1, the mean from group 1, and then it subtracts the value from group 2, the mean from group 2. And in this particular case, the mean from group 2, the experimental group, was larger than the mean for group 1. So that's why we see a negative t-value in this situation, but positive t-values in the two examples that we looked at previously. Regardless of whether that value is negative or positive, a value of 0.72 is a relatively small t-value, so I'm not expecting it to be statistically significant. Again, we had 98 degrees of freedom, and here I can see that exact p-value, and I want to compare that to 5%, 0.05. That says 0.47. Of course, 0.47 is not less than 0.05, so we do not have statistically significant results. In other words, it's quite likely to find these differences just due to sampling error. It's quite likely to find these group differences just due to chance. We have not effectively ruled out chance as a viable explanation for the differences that we see. So this result is not statistically significant. Again, here is the mean difference, the difference between those group means. Here's a standard error of that difference, and here's a confidence interval around that difference. And again, we can see that that confidence interval includes 0, and that signifies that we do not have statistically significant results. And in fact, that Cohen's d value is actually very small as well. So that's all consistent with finding no group differences. This is how that particular t-test would be summarized in a research report or in a journal article. We conducted a t-test with 98 degrees of freedom, and the value that we found was negative 0.72. The p-value was equal to 0.472. So again, we can see from that this result is not statistically significant. That's based on a two-tailed test with a Cohen's d value of negative 0.14. I know that it can be confusing to interpret statistical analyses like these, but the three examples that I went over should help you interpret your own statistical analyses. And of course, if you have any questions, you can just let me know. So let's finish up. Let's take a look at our instructions. That brings us to about this point right here. That means it's time to think about submitting your work. So just make sure you follow the instructions and you submit your work appropriately. Well, that's it for this assignment, but stay tuned because I'll have more to say about research methods in the next video.